we're talking about where it starts. I'm talking specifically about the y-intercept of a graph, right? I'm talking about this point right here. Whatever point that is, wherever it is, what is the x-coordinate of that point? 0. Always, right? That's always going to be 0 and the y-intercept, okay? When I'm talking about where it starts, I'm talking about when x is 0. What's our initial startup cost before we've sold anything, right? What's happening at x equals 0? That's what I'm talking about when I say where it starts. So here, I can see this first example, right? It's not too tough. I can see that it's starting at -7. Initially, when x is 0, my y is -7. And then I'm looking at, okay, how is it changing, right? And how is this graph changing? What's going to happening each time? Down by 4, right? It's essentially like if we think about this as a business, things are looking bad because you are losing money, right? Okay, so it's going down by 4 each time. So here's a quick question, right? From 2 to 5, Mariah's going to get this one from your homework. From 2 to 5, I skip how many spaces? 3. So if I normally am going down by 4 for 1x, right? If I'm going down by 4 for 1 space, but now I'm going to go by 3 spaces, how many did I skip? I skipped 12, yeah? You guys hearing what I'm saying? Right? If I decrease by 4 for 1x, I'm going to be in 3 x's, right, from 2 to 5, I'm going to decrease by a total of 12. Are we okay with that? Cool. Thanks for doing that math for me. And so my rule here, again, would be it starts at -7 and it's going down by 4 each time. That would be the rule. It starts at -7, goes down by 4 each time. Another way to say that, it has a y-intercept of -7 and a slope of -4. Okay? Y-intercept of -7, slope of -4. Okay? Let's talk about graphing that real quick just because we can. Graphing this, right, I'm going to make graphs. I'm just going to do horizontal notes because I feel like it. I've never done that before. So, okay, here, if I'm graphing this, it's going to be a steep graph. Steep.
Do that.
What was that? Horrible. Don't. You're right. Don't do that ever again.
Please.
1, 2, 3, 4, -6, -8, -10. 1, 2, 3, 4, 2, 4. Make a graph. Make a graph. Make a graph. Okay? Make a graph. Make a graph. Make a graph. We're going to graph this. I don't even think we've officially graphed in here yet. Have we? We haven't. Not officially. Not officially. Not the way I want it to be official. Okay? Again, when I'm graphing, again, I'm going to do the same 2 things. Same 2 questions. Where does it start? How's it changing? Where's it start? How's it changing? I'm going to say that all semester long. Okay. It starts at where? -7. I could also use the table, which is nice, right? I could also just graph those points from my table, but it starts at -7 and it goes down by 4 for every 1x. Down by 4 for every 1x. So it started at -7, went down by 4, and of course I could also see that my second point on the graph is 1, -11. And I only need 2 points to make a line. So I could keep going if I really wanted to, but I don't. I only need 2 points to make a line, okay? So with that, I'm going to go ahead and graph my line. Right, so this would be the graph of that thing. So now we have table, rule, graph. I love table, rule, graph. I love having all 3. It's going to be a thing. It's a thing that I have. Okay? Table, rule, graph. All right? So, looking at this second table, moving on to the second table, who can tell me how much it's changing by? AKA, what's the slope for this second one? How do you know? Who said 6? How do you know 6, Liam? I have no idea what 0 is. How can I go backwards? How do I know 6, though? I don't know where you're getting 6 from.
You get it from the 3
Act
and
like
the
you're
4.
teaching someone. You gotta say everything.
You get it from the 3 and the 4. 4 is only down.
3. Oh.
Me, Liam,
Yes,
you
3
know
and
this.
4.
Are we okay? What about what Arden's saying, Liam? He's saying you get it from the 3 and the 4.
Yes, because the 4 is 10. 10 minus 6 is the 4 that's 3 columns.
And then it's 1, 2, 1 to 2, and you skip 2 and 1, so
You
you
skip
skip minus
2.
12.
What's 2?
2
0
is
would be negative
2 is negative 2?
yes.
Are you guys okay? Does anyone know what's happening over on this side of the room? No. Cool. Okay. From this west side of the room, the west side over here is saying that because between 3 and 4 there's only a space of 1x, right? That's how I can tell how what is doing each time for each x. So from 4 to 10, right, I'm adding 6. From 4 to 10 I add 6. So then they're like, well, if you go backwards, notice 2 was skipped on the table. They said if you go backwards and you filled in 2, 4 minus 6 would be negative 2. If you went backwards again, 2 minus 6 would be negative 8. And then back to where Liam was like 6 spaces ahead in his brain, which is cool. If you went backwards again, Liam, what happened? Don't say no, how dare you?
Okay, that was not talking. I'm telling Miss Morton he said that.
I don't know what he just said.
We read this thing called our deepest fear. We have to read it every year for Miss Morgan. And it says your claim is not the Dawson rule. And we said it so. Miss Morgan, she's gonna be so
Negative 14? All right. Thank you, Liam. Liam came back, don't worry. So it's negative 14 if I go back again. Is that right, mental math? Okay,
I would just like to say I got that wrong, but right at the same time.
that's not a thing.
I thought 4 minus 6 was negative.
So here, this is important. What's this change I'm talking about really called again?
Right. Just
Okay, this change I'm talking about is slope. Really, the most important piece of lines are their slopes. The most important piece is their slope because with their slope I can do a bunch of other stuff. Okay, so once I have the slope, I can go back to find the y-intercept. If I only had the y-intercept and no slope, I might be a little hard pressed to write the equation. But again, I'll say that it starts at negative 14 and you're adding 6x every time. I'm not going to graph that one because the numbers are too big. All right. Okay?
Alright.
Here, now, I'm trying to trick you. Trying to trick you.
Oh, with your badly written 5?
Oh my lord. Wait, I thought that was a 3.
That's a good question. I don't know what number that was supposed to be. It was a 5, of course. You know it's a 5 because it had the hat, okay? You guys know how I write my 5. 5 has hats. You guys, you know that. 5 has hats. Stop it. You messing me up. First you act like you're on my side, and then you make fun of me. It's a classic bait and switch technique.
It's all because he has the hat.
I guess. Okay. Obviously it was a 5. Here's the next thing I need to think about. Because then as I was walking around, lots of you guys were like, okay, I'm cool on A. B's fine. What the heck though? Okay. Looking at this one, here's the piece that's a little bit tricky is there's no x's right next to each other. Right? There's no like 3 then 4 or 2 then 1 then 2. Okay? But so all I need to think about is okay, on average, from 5 to 8, how much did it increase?
3.
Yes. Sorry, it took me a second. From 5 to 8, it increased 3. And from 6.5 to 8, how much did it increase?
1.5.
Is that true?
But isn't it negative
No.
6.5?
No. That's just
It's
a...
way more than 1.5.
Really?
That's
Really?
That's what messed all of us up.
You guys,
Yes.
that was just my hand smudge.
It's just, she has the evidence of the little
Look!
smudge.
Look it down here. My hand smudged it.
But we can see that.
This is all your
Yeah, you guys, look at the pattern, you guys. That's not even logical.
But
I'm
it was
sorry.
there.
Okay.
This.
I was thinking for myself.
Then why did you do it?
Because I thought it was negative.
You know, I thought that because this was our second year together, things would get easier. It only seems that they're getting harder. I don't know.
I did. We love you.
God. You know, that wasn't a strong negative. It was just a little smudge, okay? Yeah, Johan.
Just do it.
God, we're never. Is it Friday?
No, tomorrow's Friday.
You don't get a break yet.
52. We got 30 more minutes. Okay, here we go. Okay.
We could just go.
Obviously, it was a positive 6.5, and obviously, my question remains. Come back. It jumps 3 on the x, and from 6.5 to 8 is how much?
1.5.
Cool. So if in 3 changes of x, right? In 3 spaces of x, my y changes by 1.5. How much does it change for 1 change of x? Go. 0.5, right? Because if it's 0.5, essentially what I could do also is I could expand this table out, right? I could say 5, 6, 7, 5, 6, 7, 8. No one went there with me. Thanks a lot.
I was gonna go, but
Okay.
I
So again, if this is overall, over the course of those 3, Arden. Over the course of all 3 of those spaces, it goes up 1.5. That means it's going up a change of 0.5 each time, right? So that this would be 7, right? This would be 7.5, 0.5, right? 0.5, 0.5, okay? And if that's the case, right, I can also use that. Shh, Arden. If I know my change each time, I know my slope for every 1x, I can also use that then to work backwards, of course, right? To expand my table backwards to find out that initial value, right? I know 0, I don't know 0, but I know 2 is 5. So if I want to go ahead and work backwards off of 5, I know that 1 would have been 4.5, making 0, 4, so that I can write my rule as it starts at 4, plus I'm going to write this as a half x because I feel like it. Okay? So here is the rule for that last one. Okay. Yes.
So are these always going to be functions? Like the table things?
Pretty much in here, yes. Okay, these are always be functions.
Not
Well, when we get to up higher, more advanced math, they won't be. But yes.
And then also, do you remember why it's 4 plus half?
It's 4 plus a half and it's not 5 plus a half because the starting value, right? When I'm talking about where it starts, I'm talking about the y-intercept. And the y-intercept always happens when x is 0. So every time I talk about starting value or y-intercept or startup cost, we're talking about when x is equal to 0. Okay? Not necessarily just the start of my table, right? So if you had 5 plus half x, or you thought that was negative, whatever, right? I'm talking about the start of my table, so I may need to go back and find that initial value. Okay? All right. Here's what we're going to do today. Are there questions on homework? It's going to be the first time I think ever I'm skipping going over. You want the answers real quick?
I would like to check it. I would like to
Huh?
check it. I want to
You
improve.
don't want the answers?
Oh my.
If those of you who want the answers, I'll have my notebook up here in a second.
I don't want to.
You have to do some research. This summer, I celebrated my dog Bean's 7th birthday. I know. So, because of that, I'm making you research puppies, and that's okay. So, what?
Wait, human or dog ears?
He, like, when you were like, this is the funniest thing I've ever
Which
seen.
two are the first?
Dogs doing flips. That's what he thought you were gonna put on. Now he wants to watch them.
If you absolutely, if you're not a dog, you don't want to look up dog breeds, too bad for you. Okay? So you are gonna. Here's essentially. I'm gonna give you a quick summary, and then I'm gonna give you the instructions are here. You are gonna use an iPad or your own technology if you'd like to research dog breeds or a dog breed. You're gonna choose a dog breed. You're gonna research it. You are gonna find out two things. One, the average initial weight of a puppy at birth, and two, the average weight gain for the first 12 weeks of its life. You gotta look this stuff up. I want you to model the growth of that puppy with a table, equation, and graph. Table, equation, and graph. Yes, it is. You have roughly, you don't.